So hi everyone, welcome to my presentation. My name is Yongchao. I'm an applied machine learning engineering intern at Vector. My summer project can be summarized as building a data annotation tool using active learning and transfer learning. Here I show a typical life cycle of a machine learning application, where we have 5 different phases, namely data collection, data annotation, model training, model evaluation, and model deployment. For many real-world machine learning applications, data annotation can be a big headache, especially for the domain where a high level of expertise is needed to label the data, such as medical, law, or finance data. So the motivation question of this project is, how can we build a label-efficient machine learning system? More specifically, how can we build a data annotation tool that facilitates the data annotation process? In this project, we will utilize the recent advancement in 2 areas of machine learning to build a data annotation tool for the named entity recognition task. One is called active learning, the other is called transfer learning. So why do we want to combine these 2 techniques in the first place? The goal of active learning is to identify the most informative example from a pool of unlabeled data. By labeling this more informative data, we believe that we can train a model with a few number of labeled data. In contrast, transfer learning aims to reduce the knowledge learned from a similar domain or different domain. It can both reduce the model training time and the number of labeled data. One typical way that I use transfer learning is to train a model from a pre-trained model checkpoint rather than from scratch. As you can see, these 2 techniques both can reduce the number of label points. However, they do not overlap with each other because active learning focuses on the data side, while the transfer learning focuses on the model side. That is to say, we can take advantage of both of them. So the rest of the presentation aims to give a high-level overview of how we combine those 2 techniques to build a label-efficient machine learning system. Specifically, we will build active learning and transfer learning powered data annotation tool for the named entity recognition task. Now let's see how it works first, and then have a closer look at the technical details behind it. Now let me introduce the following 2 services to you guys. One is called named entity recognition inference service. It will give you a sense of what the named entity recognition task is. Basically, this service can take in some raw text and tell you which tokens are entities. To build this inference service, we need to train a model on labeled dataset. So to facilitate the data annotation process, we'll build the second service, the data annotation service. Yeah, as you can see here, the left panel is the front end of our service, the inference service, and which run on my local computer. And the right panel is the backend of our service, which run on one of the computing nodes on the cluster. So let's see how we can use the inference service. So basically, you can select which label you're interested in or which entities you're interested in. So now you can select all, but now I just set the default, and you need to select the model you want to use. And you can type some text and just click analyze. So the backend server, you can see in the backend server receive the raw text, raw text data, and the front end show the result. For example, the model thinks the University of Toronto is an organization, the Vector Institute is an organization, Toronto is a location. Yeah, let's look at our annotation tool. So first you need to select which data set you want to annotate. Ideally, it should be the user upload a raw text file, but now I just use a corner dataset, 2003 dataset. And you need to select which model you want to use. Now I just use a Hugging Face BERT data model to train. And then you need to define the label you're interested in. So in order to consistent with the corner 2003 dataset, I just use the default setting. Now you can select auto stretching, turn on the auto stretching, and turn on the active learning, and select the active learning algorithm you want to use, and you just click start. You will see the front end send a GET request to backend server, and it get a example bag and with some auto suggestion predicted from model. And you can see, you can move your mouse to see the confidence, how the model's confidence about the prediction. And I think this example is correct. So you can just click the down button. It will retrieve the next sample. I think this example is also right. And say like, if you don't want to don't want this data in your data sets, you can just discard it. And say like, if you think that if you think data label is wrong, you can correct it. And that's it. Yeah, this is wrong. So I just relabel it because these two tokens are actually the same entity. And you can see after we label five data points, the BERT can retrain the model again and retrieve the next batch of data to label. And you can see, yeah, another thing to mention that this is the early phase. Say like we only have 250 labeled data points. So you can see the model confidence is not very high. What happens if we train a model for like more than 1,000 label? What happens? We start another thing. So this means this is the maybe at a later phase of a data annotation process. So you can see the model become more confident about the prediction. It's very confident. Say like this example does not have any entity. Maybe you just click yes. This is also yes. If you want to see the score, the model is very confident about its prediction. Yeah, and after 5, it will retrain the model. Yeah, let's back to the slides. Yeah, let's see how we implement this data annotation tool. The figure 4 shows that the data annotation process we just did in the live demo. In the beginning, the front end receives a set of unlabeled data, and we label it and send it to the backend server. And on the backend, the model is trained on all the labeled data using transfer learning. Then we use the train model to get the prediction on all the unlabeled data, and use an active learning algorithm to compute the score for each data point. After we sort the labeled data according to the score, we send the top most informative unlabeled data to the front end for labeling. The right figure illustrated the overall structure of the annotation service. We implemented the backend using the Flask framework and implemented the front end in Vue.js. The most important component in the backend is the active learning engine, which is built using PyTorch, Bell, and Hugging Face transformer library. The active learning engine has two main functions, update model and update candidate. When you call the update model function, the active learning engine will train a model using all the labeled data using transfer learning. And when you call the update candidate function, the active learning algorithm will come in to compute the score for each data point and sort them according to the score. Thanks to the open source community like Hugging Face, we have access to a wide range of different model checkpoints. Yeah, and it's very easy to apply transfer learning in our project. So let's see an example. So the first thing you need to do is import some function from the transformer library and define the training arguments and initialize the model and the tokenizer from the model you want and define the trainer. And you can just train it. So this is how our project apply transfer learning. Very high level overview, but the setting is slightly different. Yeah. And what about the updated candidate? How does active learning works? So here I just introduced one of the active learning algorithm called maximum normalized log probability for named entity recognition tasks. The intuition of this algorithm is to select the most uncertain points. So how do we represent the uncertainty? Let xi be the R data point with n tokens. The probability of model current prediction can be computed as this one. And since different sentence may have different sentence lengths, so in order to take that into account, people propose normalized log probability, which is this one. So what does the active learning do? It just select the data with the small MNLP score. The small score means the model is less confident about its prediction. So the data is high uncertain. And the people think that providing label to that kind of data will be very helpful to the model. Yeah, that's the overview of the system. And this system is not perfect. Let's look at some limitation. The first thing I noticed that there is a significant performance gap between the real life and the literature. The right figure is from a paper called Deep Active Learning for Name Entity Recognition. We can see that all active learning algorithms achieve better performance than random baseline. Because when we fix X, the percent of words annotated, all active learning algorithms achieve a higher F1 score. However, in my experience, I found that active learning achieves similar performance to the random baseline. This may due to difference in experience setup. For example, the dataset and architecture are different, and we use transfer learning rather than training a model from scratch. However, no matter what's the root cause of such a performance gap, it suggests that we might need a more robust active learning algorithm. The second thing I noticed is that human label may not be reliable, and the noisy label can affect the model performance. Here I gave a toy example where two users give two different annotations to a single data point. The first user gives the wrong date label, and the second user does not recognize that Jeffrey Hina is a person. Both of the annotations are not perfectly correct. So we really need a data quality control mechanism to resolve the disagreements. So that would be an interesting feature for the next step. So finally, let me spend a little bit of time talking about myself. Before this internship, I just finished my undergrad study at U of T and in the science program. And after this internship, I will start my PhD with Jimmy. So this summer internship experience is a bridge between my undergrad study and graduate study. In my undergrad study, my research focused on active learning. The goal of my research is to develop a labor efficient and computationally efficient active learning algorithm for computer vision tasks. However, I did not think too much about how we can apply this algorithm to real world problems. This applied machine learning internship gave me the opportunity to create a product that uses my knowledge. Through this experience, I expand my skill set and become a full stack machine learning researcher. I believe that skill I learned this summer could help my research life in the future. And last but not least, I got a different mindset and perspective towards machine learning. Previously, I care most about the model. And algorithm. Now I think most systematically about data and the real world problem. I think I have become much clearer about what types of research I want to do in my PhD life. Yeah, that's the end of my presentation. Thank you very much.